Hello and welcome by this video. In this video we will talk about why you should be measuring heat flux, or why does temperature change. You can feel the temperature. You can feel the temperature changing. Do you want to know why? Measure heat flux. In this presentation we'll work through a couple of topics. First, I'll quickly recap what heat flux is. Secondly, we'll answer the main question of this video is why you should be measuring heat flux. I will explain why you should be measuring heat flux right now. And afterwards, I'll give some real-world examples of situations where heat flux measurement is very valuable. And at the end of the presentation, we'll quickly discuss some alternative methods you can also apply when considering heat flux. Okay, so back to the beginning. What is heat flux? Heat flux is all around us. Whenever there is heat flowing, whenever temperature is changing, there is a heat flux. It's much easier to feel heat flux than to see heat flux. For example, when you lie in the sun, or you put your hands in front of a fire, you use a hairdryer, whenever you touch anything hot, or even when you eat an ice cream, you get a sensation of heat flux. You feel the temperature changing. When we talk about heat flux, we always consider three variations. That is heat flux that is caused by radiation, heat flux that is caused by convection, movement of hot or cold air, and heat flux that is transported by what we call conduction, that is flowing through materials themselves. I won't go into much detail on these concepts right now. There are other videos available in this presentation. I want to focus on the main question is why heat flux is important and why you should be measuring this quantity. So let's get into that. The main reason you want to measure heat flux is a story about energy balance or energy budget. Heat flux tells the complete story. It will explain why something has a certain temperature and will tell you why it is changing. So this works in general for this random cube object, where the entire capacity of heat that is flowing, there is many different things going on. There is radiation coming in, there is convection playing a role, the ambient temperature is important. This material is absorbing, it's emitting, it can be isolated or not. If you want to know what the temperature of this object will be, you should measure the heat flux. If you want to understand why this temperature is changing, you should also be measuring heat flux. And this works basically for everything you can imagine. So heat flux tells a complete story. This also works for humans. So if you want to answer the question, should you wear a hat? If you walk outside, the sun is radiating on you. You're receiving hot radiation from the sun. There's a certain ambient temperature and the wind is blowing, which could be a positive or a negative effect. And if you know all these quantities, you know all these heat fluxes, you can basically calculate or find out what temperature the human being will be. Now this not only works on small scales, it works on the largest possible scales. So, for example, a very fundamental question is, why is our climate changing? Well, if you just want to answer this question, if you want to understand why the temperature of something as the Earth is changing, it's the same principle. You should measure the heat fluxes that are affecting the Earth. So the solar radiation coming in, the energy being absorbed by the surface, being transmitted by clouds, and also the infrared, the long-wave radiation that is emitted. And if you go into literature, you actually see that this is basically the fundamental principle behind the science of climate change, measuring the energy budget of the Earth. So temperature measurements are very common. And what is important to understand is a heat flux measurement is really an added value to an existing temperature measurement. You can consider this, if you want to talk metaphors, like a measurement of an electrical current adds to a measurement of a voltage. You could also say that in a situation where you measure just temperature, you're basically just measuring the status, but you're not getting any better understanding. It's like measuring the noise level, but not the direction from which the noise is coming. So let me illustrate that in this real-world scenario. Let's say you're living right here, you're standing at this viewpoint, and you want to measure the noise, so you can measure decibels of noise. But if you want to know what is the main cause, you have to be able to separate these effects. You have to also measure the direction from which the noise is coming. So to summarize, the main point is that a measurement of heat flux leads to a better understanding of any thermal situation, which allows you to make better decisions. Many situations in the real world have multiple sources of heating or cooling. For example, if you're looking at an indoor office environment where the sun is shining in and the heaters are turned on, you can actually measure which is the dominant source. Just a temperature measurement will not give you this information. So that's basically the main point. Now I want to get back to this main point when we talk about real-world examples later. But right now I want to highlight why you should be measuring heat flux right now. Heat flux measurement is now available to everyone. Measuring heat flux is very easy. So modern heat flux sensors that are now designed over the last few years are very easy to use. They require no external power, they're very flexible, and they do not compromise on quality. So they allow you to get very accurate measurements of heat flux. So to illustrate that concept is, look at this FHF sensor that is submitted to a bending test. Modern technology allows for this device to have a good, easy to use signal whenever there's a heat flux flowing, but it's also very flexible. You can see it bends quite easily, and it's not negatively affected. There is no stresses inside this sensor anymore. It's important to understand that this is really a technological advance over the last few years. Our heat flux sensors are based on a patented technology, allowing for very thin sensors, very reliable and accurate measurements. And at the same time, these instruments are still very much affordable. So that means a heat flux measurement is now more available than ever before. A very important point to understand whenever you talk about heat flux sensors is the concept of calibration. By calibrating a heat flux sensor, you're basically determining the output of that individual sensor to a heat flux. All our heat flux sensors we manufacture are individually calibrated in a very specifically designed calibration setup. So that means that you always have a good traceability and can always rely on performing an accurate measurement of heat flux. So when in the last few slides you saw just this general purpose heat flux sensor, but actually there are many different heat flux sensors around. And for a lot of applications you can imagine there already exists a dedicated solution. So if you look at this overview of heat flux sensors, you see there's a lot of variation in sizes, in coatings, in water cooling, in combinations. These are all, in the end, heat flux sensors. Some of them are general, but some of them are really designed for a specific purpose. For example, this instrument here is typically designed for fire and flame research. And here you see a small system that is used to determine the thermal comfort of an environment, and is also based on heat flux measurements. So if you have a specific application in mind, do check if there is already a solution developed for that application. Here in this overview, you see all the applications that we service right now. If you look at this slide, you see there is industry involved, there is fire and flame testing, meteorology is a market where a lot of heat flux is being measured, in thermal comfort measurement, building physics. Whenever there is a heat flowing, heat flux is an interesting quantity to measure. With these heat flux sensors also come a set of very powerful accessories. So we offer as an accessory to the heat flux sensor, for example, self-test heaters. And by self-test heaters basically allow you to repeat the calibration experiment in any setting you want, giving you a method of online quality control, really adding a lot of value to the accuracy of the heat flux measurement. For many heat flux sensors, you have the option of using black and gold stickers, which you can apply on your heat flux sensors. By applying a sticker, you're changing the reflectivity of this instrument, and it allows for detailed study of radiation and convection in situations where both of these quantities play a role. So basically, having this ability to separate radiation and convection really can improve your understanding of complicated thermal situations in a way that was not easily available earlier. When we talk about how heat flux measurement is easy, for example, you can build data logger, build big measurement systems, but for preliminary testing, there are very easy to use handheld readout units available, which basically give you a very direct number of the energy flux density or heat flux at this specific moment. So to summarize this point of why you should be measuring heat flux right now, heat flux sensors are now very widely available and they're designed to be very easy to use, while at the same time being very robust. They rely on very accurate sensor technology. Application-specific sensors are often available, and there is a very wide range of accessories that really open new doors of using a heat flux sensor in a very effective method. To illustrate the value of heat flux measurements, I want to walk through 4 real-world examples. First, we'll look at the question of what is the most effective way to save energy on heating a house. And then I'll try to answer a question on when it's a sunny day in spring and the sun sets, why does it cool down so quickly? I want to talk about terrace heaters and how you can consider whether it's big enough to heat an entire table. And finally, we're going to answer the fundamental question of what is the best way to cool my champagne. So first, let's talk about this house in winter. Let's say you want to heat this house. What is the most effective way to do that? Well, you can start by measuring the different heat fluxes that occur. For example, the heat flux through the doors and the windows could lead you to saying, I would need a draft stopper. You can measuring the heat flux to your walls, through your roofs, to your floors, to your windows. If you measure all these heat fluxes separately, you can find out what is the most efficient solution to save you the most energy. Again, by just measuring the temperature inside your house is not going to give you this information. It's really heat flux that explains what is going on. So, secondly, let me talk about this situation. It's early spring. The ambient temperature is around 16 degrees Celsius and the sun is already very low in the sky. It can be a very comfortable place to lay down and have the sun in your face. In this situation, if it's a clear sky day, you're actually losing a lot of infrared radiation to the clear air. Generally about 200 watts per meter squared of heat flux. But you're feeling a positive effect on your face because the sun is really shining directly into your face, giving you a very positive heat flux amount of 600 watts per square meter. So when we talk about heat flux, about energy budget, we consider this to be a netto exchange of heat flux of plus 400 watts per meter squared. Now what happens if this sun drops below the horizon? Immediately, this entire radiative term of the sun is lost. And while the ambient temperature hasn't really changed, it's still 16 degrees outside, all of a sudden your net exchange of a human has become this minus 200 watts per meter squared, and you will feel yourself cooling down really quickly. So by understanding what heat fluxes are and how they work, it helps you to explain this situation, answer this question. So the third point is, let's say you want to use terrace heaters. how do terrace heaters work? If you measure terrace heaters, you will find out they are actually not heating the air, they are radiative sources. So the further you step away from this terrace heater, the heat flux drops. But you'll find out that this is not a linear process. That the person that is very close to this terrace heater can experience about 4 times less radiative heat flux than the person that is twice as far away. And by measuring heat flux, you can actually determine this. So because it's radiative heat flux, it will follow with the square of the distance. So let's say if you only consider temperature measurements, you might say, well, the temperature is very similar across my table, but if you're measuring radiative heat flux, you'll find out that distance is very important to a terrace heater. So if you have a table, you have a terrace heater, make sure you're close to the heater and not on the edge of the table. So finally, for the most interesting question of these real-world examples, what is the best way to cool my champagne? For this question, I will let my colleague Kees do the talking.
Okay, another example of measuring heat flux, the art of cooling champagne. This bottle is equipped with a flexible heat flux sensor. How do you cool champagne? Possibly by putting it in the fridge. In the fridge we measure a disappointing 75 watts per square meter cooling capacity. This is why they invented the champagne cooler. Here we measure a 5 times higher heat flux of about 500 watts per square meter. Now, in order to make this work really well, we have a water-filled champagne cooler. And here, from the dry ice to the wet ice, we again win a factor of 2. We measure a staggering 1000 watts per square meter.
Well, thank you, Kees, and hopefully these examples illustrate in a real-world situation why measuring heat flux is very important and really helps you to get a better understanding of what you are doing. At the end of this presentation, I want to quickly note some alternative methods that are also available when we consider heat flux. Basically, there's 2 I want to highlight here. First is the use of thermal cameras for infrared imaging, and secondly, the use of numerical models. So let's talk about thermal cameras. These are devices which allow you to make a visual picture of the thermal environment. And it's important to understand that this is in fact temperature measurement of the complete surroundings, but it's based on emitted radiation. So the camera is measuring how much radiation it is receiving from these components and calculating a temperature. That means that it's very reliant on knowing the emissivity of the materials. If you do not know these emissivities, your temperature measurement will be off. This method is actually very useful for finding hotspots on single materials. Like if you have a piece of metal which is completely uniform, with a thermal camera, you will be able to identify hotspots or cold spots. But whenever you go into a situation where there's different materials or there is reflections from other sources, be very careful when using thermal camera measurements to calculate absolute temperatures or absolute heat fluxes. To illustrate that a little bit further, I want to talk about this story that we have on this espresso machine. Here on the left-hand side, you see an espresso machine which has 2 heat flux sensors attached on it. These are just general purpose heat flux sensors. And one of them is applied with a black sticker, and one of them is applied with a gold sticker. Now this metal plate on which they are mounted is about 45 degrees Celsius and has a very uniform temperature. If you look with a thermal camera to this situation, you get this picture on the right. And you see immediately that the black sticker looks like it's hotter than the gold sticker. This is not actually the case. The black sticker is emitting radiation, while the gold sticker does not emit any radiation at all. You can also see on this picture very clearly that both the metal connection blocks and the wires also emit radiation. In essence, this entire picture should be one single temperature. A thermal camera image is basically a combination of a temperature measurement and a heat flux measurement together. So to understand what's going on here, you have to understand the heat flux that's playing a role. If you want to measure the heat flux that is actually being emitted by this espresso machine, you should use the heat flux sensor with the gold sticker, because that's the most reliable and most similar situation thermally to the espresso machine itself. Secondly, numerical models. When people talk about heat flux, they often talk about numerical models, and there's a lot of software available that allows you to put any situations into a 3D modeling software, set some boundary conditions, material properties, and then calculate temperatures and heat fluxes. Those are extremely powerful tools and very useful in a lot of applications. But it's always important to realize that numerical results are based on assumptions. So whenever you do a numerical simulation on a real-world situation, make sure to validate those simulations. By using a heat flux measurement, you can actually prove the starting point and the finish point of your simulations. So to get this all together, whenever you can feel the temperature changing, and you want to know why, measure heat flux. Heat flux tells the complete story. It will explain why a temperature is changing, and it will give you a better understanding of any thermal situation, leading to better decisions. Next to that, heat flux sensors are now more easily available than ever before. For every budget and for every application, there is a heat flux sensor out there that can help you. And if you're interested in learning more about heat flux, there are several resources available. Check the other videos on our channel. Check the downloads on our website, where we have a lot of application notes and guides on how to use heat flux sensors. Read our brochures and manuals. And if you have any further questions, please contact us directly. With that, thank you again for listening,